Hello everyone and welcome to another video. So today I'm going to be showing you an interesting thing I've made with the animation system and explain a few changes that I'm going to have to enforce to make sure that animations are not broken. So first of all, let's just go ahead and show what happens. We have right here an interactable object, which is a lever. We can turn it on or off, and we have some platforms in here. And these platforms are going to move when we press the levers, right? So when you flick the lever up, it should move the platform that is down here, if I recall correctly. And it takes 10 seconds to activate from the moment that you press the lever, so that you have enough time to get on the platform. The lever should be right by the platform actually, or maybe on the platform itself, but yeah. I built the map like that. And now, if we pull the lever down, the platform that moves is going to be the one that is up here. And it's going to do the same. It's going to wait 10 seconds, and then it moves to the right, waits for a while, and then comes back in here, right? So yeah. That's pretty cool. And you can do this as many times as you want. You will once again activate the platform below, and it will work just fine. And we could actually, to make sure that the teleportation spell works in here properly, we could put an animated nav mesh on top of this platform to make sure that we can move on top of the platform, that enemies and AI can move on it, and that the teleport spell works in there as well. But I haven't done that yet. And this other object that we had here before, that is interactable, it still works just the same way as before. It's infinitely activatable. Or we could disable the activation like by changing a few things, like literally one line of code in the XML file. So yeah, this is looking pretty good. Now, the changes that I'm going to have to explain are sadly something that we're going to have to do to make sure that all animations work correctly, and this is sadly due to the way that Blender handles parenting. This is not really a technical requirement for the animation system, but the way Blender handles parenting makes it very easy to get things wrong. So I wanted to avoid getting any issues in the future, so I'm going to enforce a hierarchy that's going to make sure that when translating information from from the C app coordinate system to the Y app coordinate system, and from Blender's parenting system to the parenting system used by Magicka, we're going to have the most generic solution possible that works in most situations. So sadly it's going to have a little bit extra complexity, but yeah. So if we recall correctly from the previous video, this is the object I'm going to use as an example. We can come over here and look at it. And before it was just CP anim, which was a bone for the checkpoint, right? And it had its mesh, and that was it, right? There was absolutely nothing else about it. Well, now it has a root, and that is because the way that offsets work in Blender is that they are, for whatever root object, they are absolute, right? So if you've got an object that is relative to the world coordinates, any transformation that they have is going to be 100% absolute in absolute coordinates, right? Like, it's not that it's relative coordinates, and when you assign it to a parent, right, it's going to work relative to those coordinates, and then when you have the animation without any parent, it's still relative, but since it's relative to nothing, it's technically the same as global, right? It's relative to the world origin. No, there's like literally a difference between the coordinates being global and local in Blender when you parent stuff, and that breaks a lot of things. That's a big mistake that a lot of people make when they start out with Blender's parenting system, because it's somewhat different to what other games do, which is, or engines or 3D modeling programs, which is that they just recalculate those transforms to be relative to the new parent, and when you unparent them, they are going to be relative to the origin of the world. In the case of Blender, it's not like that, right? And it's really weird, but once you get how it works, you understand how it can end up affecting the scene. You get how it works. It makes sense from a certain point of view, but it's just different and maybe unintuitive, right? So what I'm going to enforce to make sure that all animations are actually local, which is how the animation data is stored in Magicka, right? I'm going to enforce that always you're going to have an unanimated parent root bone, right? So it will be an animated level part, completely empty, that only contains a root bone. And we will probably configure this by having a bone, like a type, empty type bone, and below it we will have a bone type being a parent bone or regular bone or animation bone or something like that, right? Or maybe we repurpose the hierarchy node, which I was going to get rid of, and rename into parent bone, and the rest are bones, right? So you need to always have, like, only as a way to enforce it, because technically if your object is not going to move, this is not going to be a problem at all, because it's not going to have animation data. So maybe I won't enforce this, right? Because it's more like a Blender thing rather than an animation mathematics related thing, right? So we could just have it as a convention and everyone will do it to make sure that their animations are correct. And whenever a newbie doesn't do it correctly, then all hell breaks loose and everything goes to shit. Or we could just, do things the sensible way and maybe add some kind of enforcement, right? And what it means for the point of view of the code, we can come here and look at the animation root. We can see that the checkpoint right here now has a root which has no model data at all. It does contain a vertex declaration because it has to contain a vertex declaration, but it has no model meshes at all. So yeah, it could technically contain an empty vertex declaration, but I'm not going to modify the code for that, really. It doesn't make much sense. After that, we can see that it's got an animation frame with literally just its global location, and this rotation is again a side effect of translating the coordinate system from C up to Y up, and we could correct it, but it would break all animations. So the parent bone is going to always be rotated weirdly, and that weird rotation is going to go away when we work on the relative coordinates of the child bone. So we can see that the children is just one, and is the CP anim itself. And that's the way it's going to work for basically every single object. And this one is the one that's actually going to contain the animation data that we're using, right? If we come over here to this other object, we've got the platforms, for example. We've got a platform root. Within it, we've got the platform bone itself, and then we got this mesh. And if you think about it, right, this is actually pretty much the way that the FBX files that are left over in the game files actually work, right? So this is probably the same problem that they had in Magicka when they were developing the game, and they fixed it in a very similar way. And I don't like it at all. I really don't like this solution, to be honest. But it makes sense, because if you think about it, all skeleton systems in game engines actually have to have some kind of parent bone as a reference system, right? And that's where the whole root motion stuff comes from. So I think it makes sense, right? And I think we could, if you think about it from that point of view, because most other 3D software, when you parent stuff around, it's not exactly animated parenting stuff, right? Like, it doesn't have the idea of being able to animate that component when you parent them. So that's why they work differently. In the case of Blender, it has to be more flexible, and that's why parenting is usually a bit weird, because you can animate everything, right? Even things that are not bones, and this is not a bone, right? And that's why this system is kind of manually replicated on 3ds Max when you look at the FBX files created by the developers of Magicka that they left over in the game files. So I guess this is pretty much sort of justifiable. I don't really like it, but it's a good enough solution, right? Like, it does work. And you could even go a little bit further, and we've got this object which is of type none, which englobates all of the animated objects, and you could probably even make it just a bone in and of itself, right? And it would work just fine. As long as the root never has any kind of animation data, it will translate correctly, right? The moment it has animation data, the root is going to break. because that's how it actually works if you think about it from a mathematical point of view. That's why roots usually don't have any kind of animation data unless you purposefully program it to have root motion. And that's why root motion is sometimes very hard to get when you don't know what you're doing, right? And you can get root motion to work here as well. But you do not want to have root motion because it's going to be harder to code than just having a static root. Right, so yeah, that's the way we should probably make a scenes in Magicka for now, until I figure out a better system and actually get something better than just rotating the whole scene to get the target rotation. So maybe I could just get the regular transforms and swap around some coordinates from it, and perhaps I could just go ahead and only apply that rotation when working with vertices, which is what we are trying to do, right? So I guess that could work, right? It's just that it's a bit of a pain in the ass to find the fastest and most homogeneous way of doing it in Blender, because the problem is that we're trying to do anything fancy like I used to do at the beginning actually gives us a lot of headaches because Python is very slow. So yeah, if we could work in any other language, then this would not be a problem. So the moment we start working with the whole C side of the code to actually make some kind of you know, C Python or C types or whatever, you know, an extension that's going to be like binary to actually run the code faster, then we would get rid of a lot of these problems. But for now, we have to make do with what we have until I get around actually implementing that system. So yeah, this is working pretty nicely, I think. I do like the way that it looks. And if we go over to the XML code, by the way, which is the important thing, this is the versus boat XML file, which I'm going to use a lot of as a reference. I recommend you do as well, because the FBX file left over from how they did the levels in Magicka is actually from one of those is for the versus boat level. So this XML is very useful because we got a lot of information exposed from the map. And you can see that for anything that is an animation or a highlight that depends on a subcomponent, that is, we got this animated level part, and then we got an animated level part attached to another level part. So it's a children animated level part. You go through it with the slash, right? Basically, it's just like a path in a file system, right? Or an URL. So literally, if we go back to our XML file, we can see that for the animation highlight for our interactive object, that is the lever, we've got the name of the root object, which if we come over here, it's lever root, right? The lever root, and the lever root has a lever bone within it. So this is a bone, and this is another bone, and this one is located at the 000, and it has the actual animation data, so that if we displace the lever root, this animation data will now be relative to this parent, rather than if we move the object, because if it was relative to the origin, we move the object, we play the animation, and then it would just snap back to the origin point because it's relative to the origin, you know? So yeah, basically that's a problem that we need to get rid of, and that's why we're using an intermediate root. And if you look at the way that the map does the lever, it actually does it the same way in the versus boat, which is a map that has a lever, right? So yeah, that's pretty much the way we're gonna be doing it for now. We've got the lever itself bone with the animation, and under it we've got a mesh, which can be located wherever you want. It can be scaled however you want, blah blah blah, absolutely anything you want, right? And after that we go into the code, and as you can see, this is a lever root and its child is lever. And this one is just a root that has nothing. But in the case that lever root were to have any models, for example, we can go ahead and create a cube and attach it to the lever root, right? I said attach it to the lever root. There we go. This cube we're gonna move to 0, 0, 0, and well, we already have a problem. That's right, I forgot about that. That's one of the problems I mentioned about Blender's parenting system. As you can see, it's parented, it's on 000, which is a relative location to its parent, but as you can see, it's the world origin rather than being the actual location of this object. If you want to parent things stacked properly in Blender, you're gonna have to either move the parent to 000 and then attach it, or maybe, I don't remember if this works, but parent object. Nah, it doesn't work either. No clue how we can parent it when the parent is moved. That's one of those things in Blender that I have no idea how we could fix. But yeah, the only solution that I know of is just moving the parent to the root of the world and then attaching it there. It's very fucking annoying, and that's literally part of the reason why I just hate doing things in Blender. But look at that. Okay, if you touch it without inverse, it actually works, which is weird. It kind of makes a little bit of sense, I guess, but I don't really like the implications. But anyways, yeah, as you can see, we attach it without inverse. That option works. Whatever, we can run with it. And now the lever itself is right here. If we try to move it, we're going to see that it pops back to its location for the animation, because we encoded the animation to be relative to this lever root, and since we wrote the animation to be on 000 relative to this root, then we're going to have to move the root itself if we actually want to change the position, right? So those are considerations that you have to have into account. So you might actually even want to have yet another intermediate quote-unquote root, or rather bone, but yeah, it depends on what you're doing and how you are thinking of animating it. So now we've got this thing right here, which is like a little box from which the lever is popping out, and it's not really looking too good, but you get the idea, right? Basically, it's kind of like in the boat map. It has this little thing in here, so we're going to use it as well as a way to indicate that this is a lever located in there and not just some random stick. I don't know, just further decoration. If we export it, this mesh right here will be a child to this level root, and it will have no animation, but this child animated level part will work correctly. And this whole thing that I'm explaining was about explaining why the lever root is in here. In anim highlights, you only need to put the animated level part that you want to highlight, and that would be lever root lever, right? That's the only thing. And why do we put this in here? Well, before, since we didn't have a mesh, we didn't have to put it in there, because it technically can't highlight anything, because even though it would be marked as highlighted, there's no geometry to highlight, right? Well, now, since we added this object in here that is a child to the root, then it makes sense to actually put the lever root itself into the highlight panel, so it's gonna highlight it as well. So yeah, that's another thing to have into account. And then the other thing I wanted to explain, which is the animation. When we play animations, as you can see, we only put this one right here, the lever root / lever, because that's the path within the tree of the animated level parts where we are looking for. This is the lever object is the one we want to play, and this is the one that contains the animation. And lever object, there could be thousands of animated level parts with the name lever. So how do we locate it? Well, we look for its parent, and then we look for its parent, and so on, until we find the exact path, which is going to allow us to locate exactly what animated level part we're looking for. And the same applies to playing the animation for the platform. Right here, the delay is 10, probably too big. Might change it a little bit, but I'm gonna keep it like that, right? So yeah, and now that we have this thing right here, well, we could export it and it would work just fine. So yeah, that's pretty much all I really wanted to talk about in here. Hopefully this information is going to be useful to anyone trying to make, you know, animations or whatever, or maps in Blender for Magicka. So yeah, see you in the next one. I'll keep you updated if I implement anything else that can be cool to deal with.